National Electrical Code Section 210.21a states that branch circuits required for motor loads shall not supply lighting loads. The NEC separates motor loads from lighting loads for two primary reasons. Firstly, circuit capacity. Motors draw high inrush currents when starting, which can overload the circuit if it also supplies lighting loads. Secondly, circuit protection. Lighting circuits are typically protected by overcurrent devices, for example, circuit breakers or fuses rated for lower amperage than motor circuits. If a motor draws excessive current, it may not trip the overcurrent device protecting the lighting circuit, leading to a dangerous situation. The NEC allows motors and lighting to share a circuit if certain conditions are met. Firstly, the motor is not connected to an appliance or equipment requiring only lighting circuits, for example, a fan or lamp. Secondly, the motor is not rated over 1 horsepower. Thirdly, the motor is not permanently connected to the circuit, for example, it is plugged into a receptacle. Fourthly, the circuit is protected by an overcurrent device rated for the motor amperage. Lower motors under 5 places are typically considered lighting loads and can be connected to lighting circuits. Ceiling fans are considered fans and are not subject to the same restrictions as motors. While bath fans contain motors, they are typically connected to lighting circuits because they are designed to operate at low power. In more detail, when a motor starts, it requires a significantly higher amount of current compared to its running current. This inrush current, also known as locked rotor current, can be several times the motor's normal operating current. If a lighting load is connected to the same circuit, the sudden surge in current can cause voltage drops, flickering lights, or even trip the circuit breaker. By separating motor and lighting circuits, the NEC aims to prevent these issues and ensure a stable power supply for both types of loads. Overcurrent devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. They are rated to trip or blow when the current exceeds a certain level. Lighting circuits are typically protected by lower amperage overcurrent devices compared to motor circuits. This is because lighting fixtures and appliances generally consume less power than motors. If a motor is connected to a lighting circuit and experiences a fault that causes it to draw excessive current, the overcurrent device may not trip quickly enough to prevent damage to the motor or the wiring. In some cases, the overcurrent device may not trip at all, leading to a fire hazard. The exceptions outlined in the NEC allow for some flexibility in situations where separating motor and lighting circuits is not practical or necessary. For example, a small motor rated under 1 horsepower that is plugged into a receptacle is unlikely to cause significant overloading or voltage drops on a lighting circuit. Similarly, if the motor is protected by an overcurrent device rated for its amperage, the circuit is adequately protected from overloads and short circuits. It is important to note that these exceptions are subject to specific conditions and limitations. Electrical inspectors have the authority to determine whether a particular installation meets the requirements of the NEC. When evaluating whether to allow a motor and lighting to share a circuit, an inspector will consider factors such as the motor's horsepower rating, the type of load connected to the circuit, the size of the overcurrent device, and the overall electrical system design. In the specific case of a disposal and a can light above a sink on the same circuit, the inspector likely failed the installation due to the potential for overloading the circuit and the risk of inadequate circuit protection. Disposals typically have motors that can draw a significant amount of current, especially when starting. Combining this load with a lighting load on the same circuit can increase the risk of tripping the circuit breaker or causing voltage drops. While blower motors under fireplaces, ceiling fans, and bath fans also contain motors, they are generally treated differently under the NEC. Blower motors under fireplaces are often considered lighting loads because they are typically low-power devices that operate intermittently. Ceiling fans are classified as fans, not motors, and are subject to different requirements. Bath fans, while containing motors, are typically designed to operate at low power and are often connected to lighting circuits without causing any issues. It is important to consult the NEC and local electrical codes for specific requirements related to motor and lighting circuits. A qualified electrician can help ensure that electrical installations are safe and compliant with all applicable codes and regulations. When designing or installing electrical circuits, it is essential to consider the load requirements of each device or appliance that will be connected to the circuit. This includes both the running current and the inrush current for motors. The circuit should be sized appropriately to handle the maximum load without overloading the wiring or the overcurrent device. In addition to the NEC, other standards and guidelines may also apply to electrical installations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers and the National Fire Protection Association. It is important to be familiar with all applicable standards and guidelines to ensure that electrical installations are safe and reliable. Regular inspections and maintenance of electrical systems are also crucial for preventing problems and ensuring safety. Electrical systems should be inspected periodically by a qualified electrician to identify any potential hazards or code violations. Maintenance tasks such as tightening connections, replacing worn or damaged components, and testing overcurrent devices should be performed on a regular basis to keep the electrical system in good working order. The separation of motor and lighting loads is a fundamental principle of electrical safety. By following the requirements of the NEC and other applicable codes and standards, it is possible to design and install electrical systems that are both safe and efficient. When in doubt, it is always best to consult with a qualified electrician to ensure that electrical work is performed correctly and safely. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the NEC and other applicable codes and standards to ensure that electrical installations meet current requirements. Continuing education courses, industry publications, and online resources can help electricians and other electrical professionals stay informed about the latest developments in the field. The NEC provides specific guidelines for calculating the ampacity of conductors used in electrical circuits. Ampacity is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation type, and installation conditions. When selecting conductors for motor circuits, it is important to consider the motor's full load current, starting current, and duty cycle. The conductors must be sized to handle the motor's maximum current demand without overheating. The NEC also provides requirements for the type and size of overcurrent protection devices used in motor circuits. Overcurrent protection devices are designed to protect the motor and the circuit from overloads and short circuits. The size of the overcurrent protection device must be coordinated with the motor's full load current and the conductor ampacity. The NEC allows for different types of overcurrent protection devices to be used in motor circuits, including fuses, circuit breakers, and motor overload relays. The choice of overcurrent protection device will depend on the specific application and the motor's characteristics. In addition to overcurrent protection, motor circuits may also require other types of protection, such as undervoltage protection, phase failure protection, and ground fault protection. These types of protection are designed to protect the motor from damage due to abnormal operating conditions. Undervoltage protection protects the motor from damage due to low voltage conditions. Phase failure protection protects the motor from damage due to the loss of one or more phases of the power supply. Ground fault protection protects the motor from damage due to ground faults, which can occur when a conductor comes into contact with a grounded surface. The NEC provides detailed requirements for the installation and wiring of motor circuits. These requirements cover topics such as conductor routing, conductor termination, grounding, and bonding. Proper installation and wiring are essential for ensuring the safety and reliability of motor circuits. Improperly installed or wired motor circuits can pose a significant fire hazard or shock hazard. The NEC also provides requirements for the labeling and identification of motor circuits. Motor circuits must be clearly labeled to indicate the voltage, amperage, and horsepower rating of the motor. This labeling helps to ensure that the circuit is properly maintained and that the correct replacement parts are used. When working with motor circuits, it is important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing the circuit before performing any work. Only qualified electricians should work on motor circuits. Unqualified individuals can pose a serious risk to themselves and others. The NEC is a complex and comprehensive document that covers a wide range of electrical topics. It is important to consult the NEC and other applicable codes and standards before performing any electrical work. A qualified electrician can help to ensure that electrical installations are safe and compliant with all applicable codes and regulations. Regular training and education are essential for electricians and other electrical professionals to stay up to date on the latest changes to the NEC and other applicable codes and standards. The electrical industry is constantly evolving, and it is important to keep pace with the latest developments to ensure that electrical work is performed safely and effectively. Many resources are available to help electricians and other electrical professionals stay informed about the latest changes to the NEC and other applicable codes and standards. These resources include continuing education courses, industry publications, online forums, and trade shows. By taking advantage of these resources, electrical professionals can ensure that they have the knowledge and skills necessary to perform their job safely and effectively. It's also worth remembering that local jurisdictions may have amendments or additions to the NEC. These local codes can be more stringent in the NEC, so it's important to check with the local building department to see if there are any additional requirements in place. For example, some jurisdictions may require arc fault circuit interrupters, or of size, in more locations than the NEC requires. Others may have specific rules about the type of wiring that can be used in certain areas. Checking with the local building department before starting any electrical work can help prevent costly mistakes and ensure that the work complies with all applicable codes. Another important consideration is the type of equipment being used. All electrical equipment should be listed by a recognized testing laboratory such as Underwriters Laboratories or UL. UL listing means that the equipment has been tested and found to meet certain safety standards. Using UL listed equipment can help to reduce the risk of electrical fires and other hazards. Finally, it's important to remember that electrical work can be dangerous. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. A qualified electrician has the training and experience necessary to perform electrical work safely and effectively. Trying to do electrical work yourself without the proper training can be risky and could lead to serious injury or even death. In summary, the NEC separates motor and lighting loads for safety reasons, but exceptions exist. Always consult the NEC, local codes, and a qualified electrician for specific applications.